All right, this video is in chapter 2, and it's going to help you learn how to identify how many significant digits are in a number. Now, we haven't talked really what significant digits mean, but it's something you're going to hear throughout the whole year in chemistry. And if you take physics next year, you're going to hear more about significant digits. Now, some teachers call them Sig Digs for short. So you might hear me use that phrase, or Ms. Kaufman or Ms. King use that phrase as well, and it just stands for, it's short for significant digits. Some teachers call them significant figures, and will say sig figs. So don't get hung up on that. It's all referring to the same thing. And what it means is it's a system that scientists have developed to try to deal with the fact that measurement always contains some uncertainty. So we are going to use significant digits in our measurements and in our calculations throughout the whole school year. So significant digits are something that you not only have to know now to pass the Chapter 2 exam, but you will use in every calculation that you do this year. So this is extremely important to learn. Now, the first thing we want to do is know how to identify what digits are significant and which ones aren't. And you're going to learn really quickly that the things that become a pain in the rear end are zeros, okay? The first rule is just telling you that non-zeros are always significant. So if you have a number, something like the number, let's say 12.75, and let's say that's grams, and you want to identify what digits in that number or measurement are significant, you would look at everything that isn't a zero. In this case, all of these digits, the 1, the 2, the 7, and the 5, are all non-zeros. Therefore, we would say that this number has 4 sig digs. And if I were you, I would copy these examples down in your note packet because it's good practice to get used to these. So there's an example of 4 significant digits. Now let's try another one. If I write down the number, let's say 213 milliliters. Okay, if I look at that, all the digits, the 2, the 1, and the 3, none of them are zeros, therefore they are all significant. This number would have 3 sig digs. So those aren't too terribly difficult to go through. Now, it's zeros that become a real pain. So let's start looking at when those become a problem. If you have a 0 and it's between non-zeros or other digits that are significant, that 0 then starts to count. Here's what I mean by that. Let's say we have the number 1.07 grams written down. Now, based on rule number 1, we know that the 1 and the 7 have to be significant because they're not zeros. Now, this 0 is trapped between the 1 and the 7, so he must count because he's between. So this number would have 3 significant digits. If I do another example, and let's make it a bigger number, let's say I make the number 1052, okay? Now this number has the digits, the 1, the 5, and the 2 would all be significant just because they're not zeros. And this 0, who's trapped between the 1 and the 5, would now become significant. So we would say that this number has 4 significant digits. Okay? So those are examples of the first 2 rules. The third rule says that zeros that are used just as placeholders are not significant. This is an example of when we have like a leading decimal. I'll show you what I mean. If we use the number 0.002734, and let's say that's a gram again. The numbers that we know, the digits that we know to be significant are the ones that are not zeros. The 2, the 7, the 3, and the 4. These zeros out here don't count as significant. And the reason that they don't count as significant is because they are just holding the place. They are telling us where the 2, the 7, the 3, and the 4 should live. And so we would say that this number has 4 digits that are significant. Okay, so number 3 to me refers to leading decimals, leading zeros of decimal numbers. They never count. Now, what if I were to incorporate some of these other rules? Let's do something like this. What if I have 0.050602? Okay, how many digits in that number are significant? Now, see if you can get it on your own, but if you can't, you can listen and follow along. We know that anything that isn't a 0 is significant. So we know that the 5, the 6, and the 2 count. We also know, based on rule number 2, that zeros that are trapped between must be significant. So those 2 zeros count. These zeros here are left to be placeholders, these zeros out in front. They do not count as significant. So I only have 1, 2, 3, 4, 5 sig digs. So I'd say 5 significant digits. Okay. Hopefully you're getting kind of used to this now. Okay, so that takes care of zeros that are at the beginning of decimals. It takes care of zeros that are between numbers. Now what happens when zeros are at the end of a number? Well, what happens here is you have to pay attention to where they are in relation to the decimal point. The first rule, number 4, says zeros that are at the end of the number and to the right of the decimal are significant. So they have to be both. An example of this might be something like 13.50. If you look at this 0 right here, he's at the end of the number and he's on the right side of the decimal. Okay, so let's decide, does he count? Well, based on where he lives, that rule says he is significant. The 1 and the 3 and the 5 have to be significant because they're not zeros. So we would say this number has 4 sig digs. What would I do in the case of something like 9.0? How many significant digits do you think that number has? Think about it for a moment. The 9 has to be significant because it's not a 0. This 0 is the last number, and he is on the right side of the decimal. So this number has 2 digits that are significant. Okay, one last example to illustrate this rule. What if I were to have more than 1 0 after the decimal? What if it would be a number something like 5.1000? In that case, what numbers are significant? Think about it for yourself and see if you can kind of come up with the answer. But we know that the 5 and the 1 have to be significant because they're not zeros. The 0 that is at the end of the number and to the right of the decimal, so this last 0 has to be significant because he's both at the end of the number and on the right side of the decimal. And then the 2 that are squished between automatically become significant because they're between. So this digit has all 5 digits are significant. Okay, last rule for identifying significant digits. Last rule. That zeros at the end of the number that are on the left side of the decimal may or may not be significant. And to rule out any question, you'd have to use scientific notation to decide. I'm going to show you what I mean by this. This would be a number like 2,500. Okay? If you're looking at this number, all you know for sure is that the 2 and the 5 count because they're not zeros. Now, the decimal point normally lives right here, but he's not drawn in. So without him there, we don't know if these zeros are supposed to be considered significant or not. According to the rule, they may or may not be. So I would write this number in scientific notation. Now, if I wanted to have this to have 2 sig digs, I could write it as 2.5. Remember, you're sliding your decimal to a number between 1 and 10. And because I slid it 3 places, I would say times 10 to the 3. So this number would have 2 significant digits. If I wanted it to have 3 significant digits, I could still do it. I just would have to change how I wrote it in scientific notation. Instead of writing 2.5, now I would write 2.50 times 10 to the 3rd. The number is still, both of these still are represented by 2,500, but now I have 1, 2, And because this is the last zero on the right side of the decimal, that's now significant. So this one is a little different than the one above it, as it has more digits that count, more significant digits. Now, if I wanted to show this with 4 significant digits, I have 2 ways of doing this. I could either write it in scientific notation as 2.500 times 10 to the third, or, and this is the easier way, I can just draw it, the decimal point in. Now, when scientists do this, they're indicating that they want everything up to the decimal point to be significant. And so when this is done, this is showing you that either one of these numbers have 4 sig digs. The rule that I tell my students is that you should never have a number like this number right here. You should never have a big number that ends in zeros. If you end up with a big number that ends in zeros, you should always change it to scientific notation. Now, I want you to try the learning check to practice identifying how many digits in a number are significant. So don't forget to do the learning check. Good luck.